right, let's go through the pre-test. So number one, simplify the radical using your calculator, round to 2 decimal places. So all you have to do is go to your calculator, find your square root button, and then type in 75 and hit enter, and round to 2 decimal places. So this is 8.660. I'm going to write that down. 8.660254038. This is the decimal place I want to round to, so this is the number I'm going to look at. Whoops, you can't see that. So if this is 4 or less, I'm going to keep it 6, so this would just be 8.66. Number 2 says, find the length of the hypotenuse using the Pythagorean theorem. And they give you this triangle. So they tell you that this here is the square root of 21. This is 10, and here's your hypotenuse. And they want you to use the Pythagorean theorem. So remember, your Pythagorean theorem is a squared plus b squared equals c squared. They've already labeled the hypotenuse c for you. It doesn't matter which one of these you call a or b, so I'm going to call that one a and that one b. But you could have done it the opposite. It's not going to matter. So a squared is 10, so this would be 10 squared plus b is the square root of 21 squared equals c squared. Well, 10 squared is 10 times 10, so that's 100 plus, well, the square root of 21, remember when you square a square root, you get the number back again. So this would be 21 equals c squared. This would be 121 equals c squared. In order to get the answer, I'm going to take the square root of both sides. So I'm going to get c equals plus or minus the square root of 121. If you go to your calculator, you'll find out that c equals 11. Remember that because I'm talking about the side of a triangle, I'm going to throw the negative answer away, and I'm just going to keep the 11. So let's now take a look at number 3. Number 3 says, find the length of the hypotenuse in a 45, 45, 90 triangle. Leave your answer in radical form. So they give you this triangle here, and they tell you it's a 45, 45, 90 triangle. And they tell you that this is 9 and this is x. So if you remember the pattern, right? This here is a side, so we'll call that x. This here is another side, we'll call that x. And I probably should have used a different variable. Let's use that. We'll call this y. We'll call this y. And so we'll call this one y times the square root of 2. So in this case, we know that y is 9. So we know that this side is also 9, but it didn't really ask us for that. So if y is 9, we know that this side has to be 9 times the square root of 2. So this side here would be 9 times the square root of 2. Number 4 gives us a 30, 60, 90 triangle. And it tells us this is 60 degrees, and this here is 30 degrees. And what they give me is the hypotenuse and the long side. Remember, in a 30, 60, 90 triangle, the short side is opposite the 30 degrees. The long side is opposite the 60 degrees, and the hypotenuse is opposite the 90. So if we look at your pattern, again, I'm not going to use x because they have x here. Let's use side. And this would be side times the square root of 3, and this would be 2 times the side, or the short side. So if I look at this, I know this is 5 times the square root of 3, which means this would really be the short times the square root of 3, the short side times the square root of 3. So that means I know the short side has to be 5. Well, if the short side is 5, this is 2 times the short side, so I know that has to be 10. And number 5 is a little trickier. They give you this here. Let's see. And they tell you this here is 30 degrees. And they tell you this one here is 60. And, oh, maybe it's not really that tricky here. So if you, again, think about what they give you across from the 30 is the short side. So I'm going to call that S. Across from the 60 is the long side, so that's going to be s times the square root of 3. And then across from that right angle is 2 times s, because that's your hypotenuse. Well, if s is 15, I just have to substitute that in here. So I know my long side is 15 times the square root of 3. And then it's number 6 says use a calculator to find the trig value. And they want you to round to 4 decimal places. So you're just going to go to your calculator. They're not trying to find an angle measure because they already give you the angle measure. So you're going to use your regular tangent button. Just go tangent 15 and hit enter, and it'll be 0.26. So the tangent of 15 degrees is 0.2679 if they want you to round to 4 decimal places. And the sine of 27 degrees, again, you're just going to use the sine button 27 and hit enter, and it's going to be 0.45. Now it's 399. So if I want to round to this decimal place, I have to look at this one. Since this is bigger than 4, I'm going to round up. So this would be 0.4540. So I'm going to change the 39 to a 40. And then number 7 says that find the tangent of angle A as a fraction. So here they give me a triangle. And they tell me this is 3 times the square root of 10, and this is 9, and this is the angle A that we're looking at. So let's go ahead and mark what we know. If this is the angle I'm looking at, this is the one furthest away, so this is the opposite. This is the one right next to it, so this would be the adjacent. Opposite the 90 degrees is my hypotenuse. If I remember my trig functions, the tangent of some angle is going to be my opposite over my adjacent. If I look at this, my opposite is 3. My adjacent is 9. So the tangent is 3/9, but I can simplify that fraction by dividing numerator and denominator by 3. So the tangent would be 1/3 or 0.333. And then number 8 says, use the diagram to determine the value of C. So here I have a diagram. And I have, this is 13 and this is 6. And they want me to find the value of C. Well, I don't know the angles at all. Don't have any idea what the angles are, so I can't assume that it's a 45, 45, 90 or a 30, 60, 90. But I have 2 sides, so if I have 2 sides, I can solve for the third side using the Pythagorean theorem. So I can say, call this A and call this B. So I can say A squared plus B squared equals C squared. 13 squared plus 6 squared equals C squared. 13 squared is 169. 6 squared is 36 equals C squared. Going to add these two together. 169 plus 36 is 205 equals C squared. If I want to find what C is, I'm going to have to take the square root of both sides. So I know that C is going to be the square root of 205. Again, plus or minus, but because I'm talking about a side length, I'm only going to keep the positive answer. Go to my calculator, go the square root of 205, hit enter, and I know that C is 14.3 if it asked me to round to 1 decimal place. So 14.3. And then it also said find the measurement of angle A. And so this here is measurement of angle A. So now I'm going to have to use trig because I want to find an angle measure. So again, I'm going to pretend I don't know C. I'm just going to use those 2 values right here. So based on angle A, this one here is going to be the opposite. This is going to be the adjacent. This is the hypotenuse. I don't know anything about the hypotenuse, so I'm just going to ignore that one. I have to say, well, which function uses the opposite and the adjacent? So I know the tangent of A is going to be the opposite over the adjacent. The tangent of A is the opposite, which is 6, over the adjacent, which is 13. I'm trying to find an angle measure, so now I have to use that second button on my calculator. So I'm going to go second tangent, 6 divided by 13. And it's going to be 24.7, so 25 degrees. So I know the measure of angle A is 25 degrees. And the last question says, determine the angle measure if the sine of A is 0.63. Well, once again, they're asking you for an angle measure. So they're telling you that the sine of A is 0.63. I want to find the angle, so I'm going to have to use that second button on my calculator. So I'm going to go second sine 0.63 and hit enter, and it'll be 39 degrees. So I know the measurement of angle A is 39 degrees. So if you have any questions on that, let me know.